Newton's first law stated that every object continues state of rest or motion until and unless it acted upon by some external force. Now today we're going to discuss about inertia. Inertia is what? Inertia is the inability of an object to change its state of rest or motion on its own. Since it is the inability, means the object is not able to change its state on its own. On what factor does it depend? For example, there is an object of lighter mass, another object of heavier mass, and we want to move any of them. So in which case you expect you have to apply more force. Just see here. Let's say we have mass m, small m. This capital M mass is much greater than the small m mass. Now since this capital M is a greater mass, so you have to apply greater force to make it to move instead of this smaller one. Let's consider an object which are in motion already. So in which case you expect you have to apply more force to seize the motion. Obviously in the case of greater mass. So hence we can say that inertia is the measure of mass actually. Or you can say mass gives us the idea about inertia. More the mass, more the inertia. Less the mass, less the inertia. As simple. Now let's talk about different types of inertia. So we have three types of inertia. Namely, inertia of motion, inertia of rest, and inertia of direction. Inertia of motion, the very first one, it says an object which is in motion already, it will remain in its motion until it is acted upon by external force, or the object has a tendency to remain in motion only. Let's try to understand with the help of an example. Let's say you are sitting in a bus and bus is going on the road and the driver suddenly hits the brake. Then what do you expect will happen? Yeah, you're thinking, right? Your body will lean forward. The leaning forward of the body is justified by inertia of motion only. Since you are sitting in the bus, your lower body is at rest. It is as the driver hits the brake, the body sees its motion from the lower part. But the upper body still wants to be in state of motion. That's why it leans forward. I hope this inertia of motion is clear now. If we talk about inertia of rest, it is a vice versa. Means the object is at rest and it wants to bring it into motion. It has the tendency to remain at rest. Same example, let's consider this time the object is at rest and suddenly starts moving. Let's say you are sitting in your car and the car suddenly starts moving. What will happen? Your body will lean backwards. The leaning backward justifies that your lower body was in contact with the car. So as the car moves, your lower body also starts moving. But the upper body wants to be at rest. So upper body is left behind, lower body starts with the motion. That's why you feel a backward jerk. So I hope inertia of rest is clear. Now the next one, inertia of direction. As the name itself suggests that, here we will be talking about the direction. Let's say you are sitting in your car and car is going on a banked road or a curved road we are talking here. So let's say this is your curved road and you are going through it. Now as the car takes the turn, what do you expect will happen? Your body will lean outward. Then why our body is leaning outward? The answer is simple, because it has a tendency to remain in the same direction. As the car takes the turn, the car has taken the turn because of the engine power. But your body has a tendency to remain in the same direction of motion. So as a result, your body leans outward. Another example for inertia of direction can be the mud which comes out from the tires of the vehicle. Right, as the car moves, the mud is generally thrown out tangentially. See here. If this is the car tire which is rolling and it's moving forward, then this will be the direction in which the mud will be coming out. So this direction suggests inertia of direction. Since the mud is in motion, it is supposed to move with the tire itself, but it has a tendency to retain its direction. So as a result, it just flies off. So these are the three types of inertia: inertia of motion, inertia of rest, and inertia of direction. And if I say what is a measure of inertia, that is the mass. The mass is the one which gives us the idea that how much inertia a body is carrying in it. So let's move on. Now, next topic we are taking is momentum. Have you heard this term before? Momentum. Momentum is what? Momentum is actually the total motion contained in a body, or how much motion a body possesses is the momentum. Let's say you have two things. One is your tennis ball, other is your cricket ball. This is your tennis ball and that's your cricket ball. Alright, these are two balls, one is tennis, other one is cricket. Now in this case, we are having both the balls moving with the same velocity v. One is your tennis ball, other one is your cricket ball. Both the balls are going with the same velocity. Now, which ball will be harder to hold or catch, the tennis one or the cricket one? Obvious answer will be the cricket ball. And you are very true. This cricket ball will be a lot harder to catch in comparison to your tennis ball. Let's take another example. Let's say you have two vehicles on the road. One is a truck and one is a cycle, a bicycle. Both are going at a very slow speed. Truck as well as bicycle. This low speed truck is still sufficient to cause a fatal injury, whereas this bicycle will not be causing any sort of injury. Again, both are going with the same speed, that to a very low speed. So what is the reason behind that? Why the truck is causing more harm? The obvious answer will be mass. So mass is deciding how much motion actually the body is possessing. Now let's take another example. This time let's say you are having a bullet that comes out from a gun. So a bullet of very little mass, let's say 100 or 150 grams, is moving with a very high velocity. Velocity of 150 or 200 meters per second. So what do you expect will happen if it hits your body? You can even die, or it can cause a very fatal injury again. So here the mass is very small but velocity is very high. So one thing we can conclude from this example is that the motion is being depending upon two factors. One is mass and other is velocity. That's why we have concluded that momentum, denoted by symbol P, is given by mv. Your momentum is the product of mass and velocity. More the mass, more the momentum, more the velocity, more the momentum. I hope this is clear now that momentum is depending upon the product of mass and velocity. So if you find a question where you are supposed to calculate the momentum, you should have any of these two values, either mass or momentum or the velocity. Then only you can apply the expression. Let's say you have this question, the mass is given as 200 grams and velocity as 20 meters per second. Now in physics you have to remember one thing, that whenever you apply mathematical formula, the units should be in SI form only. So mass is given in grams and we know that it is in kilogram. So this has to be converted by dividing by 1000. This gives us mass as 0.2. So we have mass as 0.2 kilogram, velocity as 20, 0.2 into 20, which gives us 4 kilogram meter per second. That's your momentum. Now if you are thinking how this unit came into existence, you can just look here. We have formula as mass into velocity. Unit for mass is kilogram and unit for velocity is meter per second. Just writing all them together, we have kilogram meter per second as the unit for momentum. Then you may find questions where you have to compare that how the momentum will change if you are changing the mass or velocity. For that you can look here. Let's say we have certain momentum P which is given by mv, and I just doubled the mass. Let's say m dash is a twice of m. So what do you expect will happen to the momentum if the velocity is kept the same? As you can see here, for mass it will be replaced by 2m into v, it will be twice into mv equal to twice p. So the new momentum will be twice the previous momentum. So what we are doing here is just take care of the formula, change the values as given in the question, then you can get your result. Okay, let's say one question where the velocity is being changed, or we just say both the factors are changed together. Okay, so we will changing both mass as well as velocity. So here mass, first momentum is given by mv, and we are saying that new mass is the half of old one, new velocity is also half of old one. So what about the new momentum? The new momentum will be new mass, that is m by 2, new velocity v by 2, we have mv by 4, which gives us p by 4. So your new momentum will be 1/4 of the old momentum. So with this we conclude this topic of momentum. So I hope this is clear now. What is inertia we have done today? The three types of inertia: inertia of motion, inertia of rest, inertia of direction. And we also discuss about the momentum, a brief idea about momentum. What is momentum? What is its mathematical formula? What was the unit of momentum? How we can apply it to the questions. So in our upcoming video, we'll be talking about the Newton's second law, which was force is equal to mass into acceleration. We'll be dealing with that in detail. So till then, just revise the topic and just practice questions on that.